Alright, so I am back at it again after about 5 months of inactivity. List of excuses, but I am here. Let's talk about private access to EC2 instances. So as far as I remember, getting into private instances or virtual machines has been a little bit of an exercise where you literally use a jump box or what's called a Bastion instance to first log in and then again use another set of credentials to log into the target machine. This is usually done because you would have these target machines in private networks that are not typically exposed to outside traffic. So you need kind of a trusted path to reach these instances. And in this process, you have to kind of maintain another virtual machine as well, because you need to kind of securely maintain this Bastion host. You have to keep the Bastion host updated, restrict who can access the instance, who can leave stuff, who can write stuff. All of those considerations are there, especially because this Bastion host would be exposed to outside traffic. If we take a look at what this architecture would be in a typical scenario, usually you'd be outside of this trusted network and you would first be able to either SSH or using remote desktop access this Bastion instance, and then from there you would either have to use the same set of credentials, for example if the target instances are domain joined, or if they're not in that kind of an identity managed scenario, then you'd have to kind of store or retrieve credentials to jump again into the target instance. In a typical AWS scenario, this would be usually an EC2 instance that would be in the public subnet that would have a public IP that you'd be able to use to get into the instance. You would have to make sure that the security groups and the network access control list and the firewalls and everything else that's involved here allows traffic from certain sources, so that could be your corporate network, and then make sure that whoever logs into that instance is monitored, and also they can't do a lot of damage. The only kind of limited work that they can do is to jump into another set of target instances. When you start this process, it looks pristine. It looks clean because, yeah, of course you'd be able to log into the instance. You'd be checking the user activity and you'd do all kinds of things to make sure that things are not going wrong. But again, this is not the operationally most efficient way of doing things. As you set up agents, there's a lot of gaps for things to go wrong, and you'll ultimately end up with an instance that is shared across almost every user that would have SSH keys, RDP files, passwords, and everything else that's just available for everyone to access. And on top of that, you have to make sure that this EC2 instance is patched. Of course, there are services like Patch Manager and everything else that could automate these things, but if you are typically using a jump host, then chances are you are not probably using those advanced AWS features as well. Now, I'm not going to focus too much on the cost factor here, because usually this jump host or Bastion host could be something that's from a burstable tier instance, so it could be sense that we talk about when it comes to the daily cost. But more than cost of the resource itself, it could be operationally costly to maintain such an instance. It could be costly security wise to keep an instance exposed to outside traffic, however restricted it could be at the network layer. So in this video, I want to talk about a pattern that you can easily implement to get rid of Bastion instances like these, and just make sure that you have a very scoped, isolated, and least privileged approach to making instances available for external and internal users, and also do that in a way that you would have an auditable trail of events that happened with these instances, so that if anything goes wrong, you would know what happened, you would know which users were involved, which credentials were used, even maybe what actions were done on these instances. So we are going to talk about a couple of different AWS services. The key services that I'm going to involve in this design are AWS Organizations, AWS IAM Identity Manager, AWS Systems Manager, and also CloudTrail. So if we go into this design that I'm proposing, the root of this design or the baseline of this design is to have an AWS organization with a separate management account and spoke accounts that you can delegate different workloads into. For our design, the key governance services that we are going to need are of course, obviously AWS Organizations, and then there's another service called IAM Identity Center, which manages access to other accounts. Basically, what IAM Identity Center does is to provide roles that you can assume into and just provide a way that role assumption is easily done. So for an example, if I go into my AWS personal organization, there are a couple of accounts that I have in addition to the root management account, and I can sort of isolate different workloads between those accounts easily. And if I want to get into an account, I just have to provide access to what's called a permission set, and I can just use that permission set to assume a role into that account and keep working on it. So let's go back into the design, and in this case, the EC2 instance that we want to access is in a different account. I'm going to call that the spoke account, and in this spoke account, we have an EC2 instance inside a VPC, a typical VPC, but in this VPC, we don't necessarily have public resources that are exposed to outside traffic like an EC2 instance. We just have this EC2 instance in a private subnet. The idea is that we will access the account, go to Systems Manager, and then use System Manager to open an RDP session into the EC2 instance itself. And because we will be setting up this permission in a very granular way, when I go into that account, I will only be able to access that specific EC2 instance and not anything else. So when I set up this permission set or the SSO role that I've called here, I can make sure that the user that will be accessing this account will only be able to use System Manager, and even in System Manager only be able to use Fleet Manager, and using Fleet Manager they will only be able to access a specific EC2 instances. With that, let me just go into my AWS Sandbox account, and I will first create this EC2 instance. I will have to create a NAT gateway because I usually keep the NAT gateway deleted. I will create the NAT gateway, I will create the EC2 instance, just make sure that the EC2 instance is then registered with Systems Manager, because this is one of the prerequisites. For Fleet Manager to access a node, it should be something called a managed node. A managed node is basically something that registers itself in Systems Manager, and how that happens is the SSM agent will be able to register the EC2 instance as a managed instance in Systems Manager, provided that there is enough permissions in the instance profile that is attached to the EC2 instance, and second, the outgoing traffic to System Manager is enabled. Basically getting into the weeds here, but outgoing traffic here could go through either a VPC endpoint, or if you're not that worried about private traffic, you could basically direct this out of the internet gateway that would reach the Systems Manager public API endpoint. So that's basically what I'm going to do, and then after creating the instance, I'm going to just make sure the SSO role or the permission set is updated so that the minimum privileges are given to only access this EC2 instance. So let me just go into my Sandbox account, and I'm going to use administrate access to get into my account, just because I'm going to show different levels of access into the same account. So I could be one of the operators in the cloud, just creating instances, and then I'm going to use what's called temp SSM access, which would be another set of users, let's say business users, using to get into the account and just access the instance from outside. So if I just use the administrate access and enable JavaScript. In this case, I'm going to show that I am going to create the EC2 instance in the default VPC, just because I don't want to spin up a new VPC. I'm not using Terraform here because while it would have been easy for me to use Terraform, it's somewhat harder to demonstrate certain principles when using Terraform to create things. Just explaining the concept would be enough, I think, to understand what to build later. So again, coming back to the point, I'm going to create my EC2 instance in this default VPC. And in this default VPC, I've created a private subnet and a private route table that would basically route any traffic going outside to the NAT gateway. So first I need to create that NAT gateway. I'm going to go into NAT gateways, create one, and just call it private default 2. Just going to make this a zonal NAT gateway. Regional NAT gateways are a new kind of feature. I don't really need this NAT gateway to be highly available. I'm just going to put this NAT gateway on the same availability zone but in a public subnet. Just note that my private subnet is only in availability zone A, just trying to keep things simple, and I'm going to put the NAT gateway on the same availability zone just so that there will be minimum cross-zone traffic. Going to allocate an elastic IP, and the tag values look good. Right, and that would take some time for it to be allocated. Alright, so the NAT gateway provisioning is taking its sweet time. I'll just take you through what my route table would look like in the private subnet. So in this case, I would need to route all the public traffic, anything that is not VPC local, through the NAT gateway. So for that, I'm going to edit this route table and just make sure this points to the new NAT gateway. Right, so our NAT gateway is also provisioned, and we have made sure that the traffic is going through the NAT gateway. So anything that gets spawned inside this private subnet can reach out through the NAT gateway to outside resources. What the traffic is going to be in our case is that when the EC2 instance starts to register itself, it will reach through the NAT gateway, through the public traffic to the Systems Manager public endpoint. Okay, with that, let me go back and create a new EC2 instance. And I'm going to call this private instance 2. Private instance 1 was my trial. and I'm going to make this a Windows instance, and I just want to make this tutorial about Windows. Recently I've started working with Windows more and more, so I need to make these tutorials and the new stuff that I do more Windows oriented, not because I like Windows specifically, but I want to be better at managing Windows. So this one, I'm going to make this a T3 large, just because it's just easier to work with, because I've seen that Windows 2025 server can really struggle with a typical T3 micro instance, and I have some credit to kind of work through. I really don't need a key pair in this instance because I'm not going to use a key pair to expose the administrator password and access the system, and I'm just going to make sure this instance is created in the private subnet. So again, to iterate, I'm going to put this instance in a private subnet. It will not have a public IP attached to it. Even if it had a public IP, outside traffic will not be able to route through into the private subnet. And I already have a security group that I created in my previous run. And this security group is basically allowing outbound traffic and no inbound traffic at all. So if I go into the security groups, so you can see that there are no inbound rules, so that means nothing can actually get through, but I have enabled outbound rules to port 443, so basically allowing any HTTPS traffic to any outside destination. So just going back to instance creation flow, I'm going to allocate about 50 gigs of GP3 volume for the root volume because it's Windows, and just making sure that I am going to use spot instances for this case, because I want to make sure that I'm covering all the aspects of this video without actually worrying about the credits that I'm spending. Alright, with that I'm going to launch my instance. Now just a side note, in Windows you typically add some user data to register the volume, so if you have additional volumes you'd register those drive letters, but in this case I'm not really worried about what happens inside the instance other than the fact that the SSM agent would be running and registering itself. So speaking of, I missed that detail actually. If I can go back, here's the detail I missed. So I need to attach an IAM instance profile to this instance. So if I can go back to my diagram, I talked about how this EC2 instance needs to register itself in Systems Manager, and to do that it needs to have proper permissions. And usually how you give permissions to EC2 instances is through an instance profile. An instance profile is a way of saying that a role will be attached to the EC2 instance, and that role will be used as a principal when the instance calls out to other AWS services. So in this role, we have already attached the permissions that are needed for the SSM agent to register itself, and this permission is basically an AWS managed policy that is easy to attach. So if I go back to my AWS console, I'm going to select the private instance role that I have already created. So if I go to IAM and show you what this private instance is, it's basically just a single IAM role with SSM managed instance core policy attached. So this is a AWS managed policy, and also there's the other managed policy that allows CloudWatch agent to register itself, which is also an AWS managed policy. In this case, I don't really have to write anything in this instance profile policy. So if you go back to my blog post, you would also see that I haven't really written anything when it comes to the instance profile part of it. And when you create an instance profile, the trust relationship is kind of automatically established. So this trust relationship allows EC2 instances to assume this role. If I go back to my instance creation, I've made sure that I'm using the correct instance profile, and then going to launch instance. I'm going to proceed without a key pair. Alright, so we have our instance being created. Again, if I enable JavaScript, we have this instance running. It would take some time for the system log to come up, but instance screenshot is a better kind of a indicator on how the instance is doing. So I can see that the Windows loading thing is spinning. What I'm looking for is basically this screen. Just because you get this screen doesn't mean the instance has really started up. So I'm just going to make sure that the SSM agent is done running. That would typically be the point that we would start seeing this instance in the Fleet Manager screen. Good news, we have a lot of good signals that says that the instance is running. There is a message that says Windows is ready to use, but more than that, what I'm looking for is this log line which says SSM agent is running. So if you're following this along with my video, just make sure that you have added the correct instance profile with the correct permissions like I mentioned. Also, you have allowed public traffic to go through the NAT gateway, so that basically means that you have whitelisted outbound traffic in the security group attached to this instance, and also that you have added a NAT gateway in the public subnet that the private subnet route table will point the outside traffic into. These are typical cases that you might come across. If there is an error message here that says SSM agent cannot get the identity, that basically means it can't reach out to the systems manager service. So if you're doing ClickOps to bring this example up, then those are typical mistakes that you can do. Those are typical mistakes that I do on a daily basis. Good news is that I have tested this flow recently. I know what not to do, and in this case I do have a successful registration in Fleet Manager. So what I'm going to do is search for Systems Manager, and coming to Systems Manager, I'm just going to directly go into Fleet Manager. Now in Fleet Manager I have this list of managed nodes. I'm still in administrator access mode. That means the access I have into this account is administrator access. I don't have any access restricted, so I can basically click on this instance, go to node actions, connect, and connect with remote desktop. I'm just going to show this flow because before I start restricting access, I just want to show what the intended access would be. So in this case, when you're using Fleet Manager RDP to access a Windows instance, you can use these three approaches. You can use user credentials, which is basically getting the password for the instance using the key pair that you would have added when you launch the instance. In our case, this is not an option for us because we didn't attach a key pair. Because of that, we can't really get the password out. I think there could be ways to get a password out. You could retroactively attach a key pair and then get the password out, I think, but without going through all of that, I'm just going to use the single sign-on method. This is a really easy way to get into an EC2 instance. What it does is to basically use the credentials that I've used to get into the account to create a temporary user in the Windows instance and just get me into the instance directly. One key downside is that this would create an administrator account in the Windows instance. So if you're going after least privilege access into the instance itself, then this might not be the best way to go, especially if the instance is already kind of domain joined. This could override those domain policies. But just for this use case, I'm going to use single sign-on because I want to keep this video simple, and I'm going to click on connect. And within a couple of seconds, the screen comes up and it just starts creating the user, then provisioning the user in the Windows instance. Alright, so that was really easy. I am already in the Windows instance and things are happening. But I don't want to go into the instance itself more than I need to, so I'm going to just terminate this connection. One important detail here that is typically the session is about 60 minutes long. So if you want to renew this session for more than 60 minutes, what you basically do is go and renew the connection from here before this timer runs out. The maximum number of concurrent connections here is usually 5, but you can also increase that up to, I think, 20 or 25 connections through a support request. In most cases, I think you would be really happy with the 5 concurrent sessions and just with a 1 hour maximum session time here, because if you have other scenarios that users would be logging in and working for 8 hours straight, then this probably might not be the case for you. There are other services that might be helpful in those situations. Now that the access is done, I am just going to go back to my design and tackle the next step in our design. So far what I've used is administrator access to get into the account and create an instance. The next step would be for this instance to be exposed to restricted access users. I already have this permission set created. Just going to update the permission set policy so that the policy would point to the specific EC2 instance. So if I go back to my screen, I'm going to terminate this session and I'm going to go into my management account. And in the management account, I'm going to go into IAM Identity Center, permission sets, and I have already created a permission set called temp SSM restricted access. And in this temp restricted access, I have an inline policy that defines a set of actions that the user can do. Everything that I'm basically demoing in this video is based off of a single AWS documentation page. I have kind of modified this policy. The documentation doesn't really talk about restricting access into specific instances, but through trial and error, it's really easy to come up with a least privilege policy. So right off the bat, I want to highlight a key difference. Now, there are several permissions that you can't really restrict to resources. They have to be given based on all resource scope. Same goes with describe instance. And then I'm going to start restricting certain permissions to specific instance. I already have an instance ID defined here. I'm just going to replace this instance ID with the new instance ID I have. And also you might see that I have added another condition that says SSM resource, so the target instance should have a specific tag. Now I'm just trying to demo the fact that you can use multiple conditions or multiple resource combinations to restrict which instances or which types of instances the users will have access into. Now in this case, this is a really simple tag value combination, but in a real world situation, there could be instances based on data sensitivity or the type of data that the instance would be handling. So there could be multiple ways that you could divide the type of instances along. So you can use that divisions or tagging strategy to also make sure that users will have access to only a certain class of instances. You might remember that I forgot to tag my instance as well. I'll just go back and make sure that my instance is tagged, but before that I want to make sure that I have all the other permissions sorted. Again, I'm going to add some broad permissions and then some restricted permissions. This is basically the key permission that I'm after. SSM start session, which is only allowed on this instance and this managed instance, basically if it is done via SSM GUI Connect. So SSM GUI Connect is the service principal for Fleet Manager RDP sessions. So it's just important that we specify these conditions so that users will not be able to create new sessions into other unwanted instances. And also here again, I'm adding another additional condition that says only instances tagged with this value can be used for this start session action. There is another start session action that needs to be specified. Just because this condition is not in that specific request, I have to kind of separate the permission definition here into two statements. So start session in both cases, the action is going to be start session. The context in this request will have the SSM resource tag value, but in this request there will not be any tag value involved. So what this basically does is to allow start session action for this specific SSM document, which is needed for port forwarding between the private instance and the public basically browser that we're accessing it through. So a little bit of a minor detail, but it's something important that I figured out through trial and error. And these are the key permissions that we need for us to be able to access the RDP session through Fleet Manager, and just making sure I have the correct version of the policy. And I'm going to save this, and that's going to take a second and provision the role across the Spoke accounts that I have used these permissions for. So if I just re-log into my account, but this time using the temp SSM restrict access. So I'm just going to use a different Firefox container, and this time unfortunately I think you can't see the access level here. Basically what this says is I have temp SSM level access. So if I, for example, go into EC2, I should not be able to create instances, so there's a lot of error messages here. But instead of EC2, I'm going to go into Systems Manager, Fleet Manager, and here you can see that the node is showing up. So once again, I'm just reiterating the fact that I could not tag the instance correctly. So my instance currently does not have a tag called application with a value my application. So if I go back to Fleet Manager with the temp restricted access, if I try to RDP the way I tried before, I will get an error message here. I have not given start session permission to this instance because this instance does not have that application equals my application tag. So I'm just going to make sure that happens. that should allow us to connect to this instance again. Alright, basically what I demoed there is that you can basically control what kind of instances you need your users to be able to access. So you can control this level of access through something trivial as tags. Something to note is that I did manually update the permission set, but if you're using something like Terraform, this is really easy to do. And I also had to update the permission set because I had specifically restricted access to specific instance IDs. So just going back to the permission set in the management account. So resource specifications like this is what forced me to update the policy after I created the instance. But again, conditions like tags could actually help here, and you would not need to specify what instances. You'd only need to specify what the instance would carry. So that's basically how you would provide access to an EC2 instance from an outside perspective. So this could be users in your organization or users that are just getting into your organization to do some temporary work, which was the case in the real world work that I did this for. Also, the fact that you don't really have to set up network whitelisting or anything like that, and you only have to get the user inside your AWS organization, that makes it really easy for this work to be done. Typically in organizations, you would manage users through your external identity system, Entra ID or something else. In most cases, you would already have this external user or the internal user in that identity center, so it's just a matter of allocating the correct permission set to the user. So if I change hats for a minute and go back to the administrator mode, now I have given access to the users. Now I should be able to kind of monitor what's happening when that access is given. One way to do that would be to go to Fleet Manager and just go into the connection history. And in the connection history, it would show which users have used this facility to connect to which instances. In certain scenarios, not necessarily in this specific setup that I showed, you can also record RDP connections, RDP sessions, and store them in an S3 bucket, but that involves something new called just-in-time access, which I will try to cover in another video. But basically what this allows as an operator is to get an understanding of the usage of this facility across the organization. I would call this a starting point for investigating certain situations, just to get a brief glance on who accessed which instance at what time. But in addition to that, you can also go into CloudTrail. In CloudTrail, you can basically look for the event. So you might remember start session from the permission that I specifically granted in the permission set. So start session is that action that the users will perform to start the RDP or the PowerShell session into the instance. And you can basically treat this as an immutable auditable trail. And typically in established organizations, you would feed the CloudTrail, the organizational CloudTrail output into a security deployment like a SIEM deployment, and you would have rules that detect, for example, unusual sessions being started or sessions started in unusual hours or something. That would typically be used by more security oriented job role to figure out what's happening in real time and react to them, or near real time and react to them, I would say. But those are the two kind of key observability and traceability aspects you would have when it comes to this approach of accessing instances. Alright, so that concludes our video for now. I hope I was able to kind of get into the same flow that I had 5 months ago, explain the details, and maybe get you to try out something that you didn't try out before at your organization. Features like this are really helpful when it comes to managing least privilege principle, and also just making sure that you're not exposing details that you really don't want to outside parties. With that said, I don't know how to close this video up. Thank you so much for watching. I'll see you next week. I really need to get that light sorted out.